So far, we've learned half of the fundamental theorem of calculus. We've learned that the fundamental theorem of calculus can tell us how to integrate things like the integral from 1 to 2 of x squared by taking the antiderivative of x squared and then plugging in the numbers 1 and 2. So that's half of the fundamental theorem of calculus. Today, we're going to learn the other half of the fundamental theorem of calculus, which is going to allow us to take the derivative of an integral. So we're going to end up with problems like this one here, where we notice that we're taking the derivative of this integral. So let's do this example, and then we're going to see what happens here, try and get a shortcut. So let's start out by computing this integral, and then we'll take the derivative of that expression. So if I want to do the integral from 1 to x of cosine of t dt, I start out by finding the antiderivative of cosine, which is sine. And then I plug in my bounds, so I end up with sine of x minus sine of 1. Sine of 1 is just going to be a number. Now this problem asks me to take the derivative of that integral. So that means that I need to differentiate this expression. So I can take the derivative of that. The derivative of sine is cosine. Sine of 1 is a constant, it's just a number, so its derivative is 0. So it looks like we're getting cosine of x out for the derivative of that integral. And if we notice what happens here, that cosine was the function that was inside of my integral. It started out with cosine of t and it ended up with cosine of x, and x was the variable that was up here. So in some extent, it looks like we just plugged x in, and we got cosine of x out. That's exactly what the second half of the fundamental theorem of calculus tells us. This is actually usually called part 1, although we did them out of order. So what this tells us is if I define my function to be the integral from a number to a variable x of some function, then the derivative of this integral I get just by plugging x in. Okay, so let's do a few examples and see how this works. So this problem is asking us to take the derivative of each of the following functions. So if I notice this is set up, I've got a number on the bottom, I have an x up top, and I have a function inside. So the fundamental theorem of calculus tells me if I want to take the derivative of this integral, I just plug x into that expression. So I just get square root of 9 plus x squared out. Easy peasy. So for this next one, I have the same thing. I have a number at the bottom. I have an x up top. That is how this statement is made. So I just plug the x in. So the derivative of that integral is cosine of x squared. Notice this only works if you are being asked to find the derivative of an integral. Okay. So let's go ahead and do these other ones quickly. This might be a slightly longer video, but it's easier than doing 2 videos. So this one here, I noticed that I have an x on the bottom and a number up top. That is the wrong order. I want the number on the bottom and the x up top. So I need to flip the order of these before I can use the fundamental theorem. But if I want to flip the order of the 1 and the x, I just need a negative sign out front. Remember that property? So I still have ln of t over t squared plus 2 dt. Now my integral is set up so I have a number at the bottom and an x up top, which means fundamental theorem tells me just plug the x's in for the t's. We're still going to have that negative hanging out front. So I replace all the t's with an x, so I get ln of x over x squared plus 2. Okay, so that one just points out this little detail that we need the x up top and a number on the bottom before we can use this. Okay, so these next two are going to involve using the chain rule. So I notice here I have a cosine of x on the bottom and a number up top. So I need to start out by flipping those. I need the number on the bottom. So if I flip these, I'm going to get negative 5 to cosine e to the 3t squared dt. And now I notice that I have a cosine and not just a plain old x. And so what's going to happen when we have something that's not just a plain old x, we're going to start out the same. We're going to plug that thing in for t. So we're going to get our negative e to the 3 cosine of x quantity squared. But there's one more step that we need. We need what is essentially a chain rule step. We are going to multiply that whole expression by the derivative of cosine of x. So that derivative is negative sine of x. Okay, so we need that step here because we had something other than just a plain old x up top. Okay, so we're going to need the same thing down here because we have a number at the bottom. We have a function up top. So we start out by plugging our function in for x, so we are for t. So we get 1 plus 2x, square root 1 plus 2x. And then we need our chain rule step because this is not just an x. So we have to multiply all of this by the derivative of 1 plus 2x, which is just 2. Okay, we'll get a lot of practice with these in class.